shear force calculation. When it comes to shear force, there are these basic terms we need to know. The first one is that it is very easy to know if you are correct in shear force. Initially, the question told us to what? Draw the shear force diagram and the bending moment diagram. Before you can draw shear force diagram, you need shear force value. Before you can draw bending moment diagram, you need bending moment value. Meaning, at every point in your beam, there is this value for shear force. In general, it means that every point in your beam, you calculate shear force there. So now, how many points do I have here? We are having 3 points. What it means is that I'm calculating shear force at A, I'm calculating shear force at C, and I'm calculating shear force at B. Also know that you calculate the value of shear force twice. You calculate the value of shear force twice if these two conditions are satisfied. Now, what's the first condition? When calculating shear force at a point, you consider the algebraic sum of the forces behind that point. Are we together? I'm on a point. Me being on that point, I know that I will get to value of shear force. Abi? How do I get the first value? The algebraic sum of forces before that point. Number 2 value. The algebraic sum of forces before that point and the force at that point. Now let's apply. The first point I'm seeing here is what? What's the first point? And at A, yes. At A, let me do it here. At A, meaning x equal to what? 0 meter. You already know that we're calculating shear force value at A twice, Abi? Recall, what's the first condition when you are calculating shear force? The forces before that point. Now, let's ask ourselves, do we have any forces before that point? I'm on this point. Before this point, do I have any forces? No. It means that first condition will not hold on point A. Now, what's the second condition? Let's call the forces before that point 0. Abi? Now, what's the second condition? Meaning 0 plus the force at that point. And what's the force at that point? Is it going upward or downward? Meaning you are saying shear force value is what? 0 plus 43.3. So you have shear force value to be what? 43.3 kilonewton at A. And I'm done with that point. What's the next point? C. C, right, at C. At C, what's the value of X? 2 meter. What will be the first value of shear force? And that's what? 43 points. Are you sure? Yeah. 43.3. Before, this is it. Now, you're on this point. See, this is very confusing, but it's easy. Just know the principle. You're on point C. In your head, imagine that you are separating this beam. You are sectioning it. Break it. Say you have this. Since I'm on point C, section this beam. When I say section, you are separating. If I'm separating it, I'm left with what? I'm on point C now. I'm on point C. This is point C. Section, since we want to consider the forces before that point, which is point C, section that point or section that beam. I'll be left with what? AC. And on AC, what's the force? Okay, let me bring it out. You are not getting what I'm saying. This is point C, right? This is A. What's the force here? RAY. And RAY is what? 43.3 kilonewton. What will be the intensity of this here? 10 kilonewton. Why?
Because the magnitude remains the same.
The what? The magnitude remains the same irrespective of the length. So that's it. I'm on point C. I want to apply the first condition of shear force. The forces before that point, right? What will now be the forces before that point now? No, just tell me how many forces do I have? Is it 2, 0, or is it 3? 2. I'm having just 2. Just 2. This RAY and this U.D.L. Are you with me? What's the question?
On point C, it is 20.
Chief. What is the first condition of shear force? What is the first condition? The forces before. So the forces before. This is my diagram. Second condition now. The forces before and the force on that point. Let's draw the diagram out. So this is what I'll be having. This is RAY. 43.3 kilonewton. This is 10 kilonewton per meter. Then 10 kilonewton per meter. On point C, I'm having what? A point load, which is what? 20 kilonewton. This is the first condition. On point C, the forces before. This one and this U.D.L. That's the first condition. Number 2, the forces before and the force on that point, which is this one, and this one. Then that's it. You understand? So whenever you have a question like this, just imagine whenever you're on that point, imagine you've sectioned that beam so that you know what you are left with behind that point. Now we've identified that before point C, I'm having 2 forces which are RAY and this U.D.L. RAY is going upward, right? That will be what? 43.3 minus the U.D.L. Is it acting downward or upward? Acting downward. How do I get the force? That will be what? 10 times. Are we clear? Do you understand that part? 10 times 2. Why is it 2? Because on point C, the distance is 2 now. It is 2 and not 6. Do you understand? Just like for every point you have, it is the distance of that point you should consider. For this U.D.L, we know that the intensity remains 10 and the distance is what? 2, meaning 10 times 2. 10 times 2. You understand? It is minus because it is acting downward. Let me use the diagram. You have to get this thing. Let me use the diagram to explain.
Sorry.
First value of shear force. RAY is going upward. Abi? 43.3. The U.D.L is acting downward. Meaning, okay, if I'm putting minus 10 here, am I correct?
Yes.
If I'm putting minus 10 here, am I correct? I'm correct. Minus, why are you 10 times 2? You change the U.D.L to a point load. You understand? So you are saying 10 times 2.
My question is, before you said that U.D.L will act as center. Why not putting that out? I
get your point. Now, what are we doing now? That's the distance of the U.D.L. On a U.D.L, we have 3 points about U.D.L. Like we have 3 facts about U.D.L. The first one is converting a U.D.L to a point load. The second one is the distance of a U.D.L. So that one you are saying is the distance. But in this case, we are converting the U.D.L to a point load. In this case, what will now be the distance? What will be the distance? The distance of this U.D.L, what will be the distance? 2. Which one is correct? 2. Why is it 2? Tell me. What is the second point of a U.D.L? So if I'm from the given question, if I'm giving 2 now, what would have been the new distance? Why you're telling me 2 points? So let's continue.
I said you before that, but you said no. You said I am moving the mix up.
Let's continue. Now, this is the first value of this on point C. This is the first value of the shear force, the first value of shear force, right? And that equals to what? 43.3 minus 20. Second value. How do you get second value? On point C, the forces before that point and the forces at that point and the force at that point. Now, the forces before that point, you've gotten 23.3. What is the force at that point? Is it acting upward or downward? Downward. So you are saying the forces before that point, which is 23.3 minus 20. Why is it minus 20? The force at that point. Why are you taking minus? It is acting downward, minus 20. By the time you subtract, what's the answer? 3.3 kilonewton. At point C, do I have any shear force value to calculate again? No. Why? Because I already know that shear force is calculated twice. It must not be more than what? 2 times. So I'm done with point C. What's the next point? Point B. At point B, x is equals to 6 meters. What will be the first value of shear force? What will be the first value of shear force? You are point B now. To get the first value of shear force, consider the algebraic sum of forces before that point. Now, identify how many forces do you have behind that point, which is B now. How many forces? How many? 4 or 3? 3. Yeah, let's list it out. The first one is what? RAY. The second one is what? 20. And the third one is what? 10, which is the U.D.L. So that's it. But you can say it is 4. If the U.D.L is splitted, but there's no need of it going through that stress. Instead of just generalize it, use it as a whole. So that's what we are saying. So that's it. From here now, we are having, before that point, we are having 3 forces. We are having RAY, this point load, and this U.D.L. So it means on point C, to get the first value of shear force, I will consider RAY, I will consider this 20, and I will consider this what? U.D.L. Don't forget, acting upward, positive. Acting downward, negative. Abi? Now, that will now be what? 40. Are you getting it? That will now be what? 43.33 minus 20. Minus. Why is it minus 10 times 6? Because in this case, the distance of that U.D.L was 6. So you are saying 10 times 6. Let's get this value. That was what? There's 6.67 or 36.7. Then what will be the second value? Just recall the second condition of shear force calculation. What is the second condition? Algebraic sum of forces before and on. Before we got this. On, what do we have? 36.67. Acting upward or downward? What will be the sign? So what are you saying? Minus 36.67 plus 36.67, and this is equals to what? 0. With this, I'm very sure that my shear force is correct. Why? Because shear force must end with 0. It's very easy whenever you are solving to know that you are correct. Even before submitting that script, that confidence will be there 100. Say, sure you get. So now that's it. Biba. So, what's that?
Really there is different, like the first approach
that one we already did a point load. Now this is a series of rotated beam. No, I'll show you something.
So I had this down, but I said I think it goes to 0. But I can remember that I think my share was deep over to
so that's it, this is the approach when it comes to shear force calculation. Now the next thing is what? Bending moment. See, bending moment is the easiest one. Shade it. Now bending moment, but it will be easy only if you are a master of your moment calculation. You know, earlier we did movement, we've taken movement, abi. Once you understand that concept very well, then bending movement, you know how to issue with it. So now let's do that. Bending moment calculation. As we know that shear force has its own condition, bending moment also has its own condition. And the first one is that bending moment must start with 0 and must end with 0. Must start with 0 and must end with 0. Same approach. You calculate value of bending moment at every point in your beam. Now, how many points do you have here? 3 points, right? Bending moment at A, what will be the value? 0. At B, what will be the value? 0. But at B, without solving, you already know that it's 0. But you have to show that you know what you are doing. Meaning your calculation. By the time you get your value, this time this plus this time this minus this time this. By the time you put everything inside your calculator, input it, you must have 0. If otherwise, it means the previous value you calculated for bending moment, they are not correct. Shall you get? Now let's start. Bending moment at A. What bending moment? Bending moment equals 0, right? At A, x equals to 0 meter. The next point is what? At C, x equals to 2 meter. What will be the value of bending moment? Before point C, I'm having this support which is RAY and a U.D.L. Meaning I'm taking the moment of this support to C. I'm also taking the moment of this U.D.L to C, right? And what do I know about moment? I know that moment is what? Force times distance. So for this first one, the force is 43.3. What is the distance before getting to C? 2. So therefore, 43.3 times 2, right? The next one is this U.D.L. In what direction is this U.D.L going? Anti-clockwise. It is going like this. You are tipping it like this. Anti-clockwise. Negative. What will be the force? 10 times 2. What will be the distance? Let's get the value. Confirm. 66.6 kilonewton per meter. Yeah, force times distance. Kilonewton per meter. Kilonewton meter. The next point is what? At point B. At B, x equals to 6 meter. Without solving, bending moment will be what? Why? Because bending moment must end with 0. Okay, now let's solve. Since I know that I'm taking bending moment about point B or to point B, the force on point B will be neglected, right? Behind point B, how many forces do I have? 3. This support, which is the force in this case, this point load, and what? This U.D.L. So let's take it one by one. Considering this first one, that will be what? In what direction? In what direction? It is going like this. You are going like this. Just use this for easier understanding. The tip of that arrow. Just drag the tip of that force to that point you are traveling. So by the time you drag the tip like this, it means you have something like this. Abi? So in what direction? Clockwise. Clockwise means what? Positive. What is the force? 43.3. What is the distance? 6 times 6. I'm done with that, right? What's the next force? I'm having 20. In what direction is 20 traveling to be? Anti-clockwise. And if it is anti-clockwise, negative. What's the force? 20. What's the distance? 4. The next force is what? A U.D.L. The U.D.L is spanning from A up to B. What will be the force of this U.D.L? That will be what? How do we get 60? You at the back. What will be the force of this U.D.L? 60. How do we get 60? 10 times 6. In what direction? Anti-clockwise. Negative open bracket 10 times 60. This is just the force of the U.D.L. You need the distance. What will now be the distance? 3. Why is it 3? Because generally the distance of a U.D.L acts at the midpoint. So you are saying 1/2 times 6. Then input this in your calculator. I'm very sure that you should get 0. You should get 0. Though you might not get 0, you might be having minus 0 point or 0 point. Just like that value, you can't approximate that value to 1. It will still maintain that range. But it can be positive and it can be negative. Irrespective, it must end with 0. So let's input. What do we have? Minus 0.2, meaning bending moment at B, x equal to 6 meters is what? Minus 0.2. Then you can write approximately 0. So the first thing we did in shear force and bending moment calculation, we calculated the support reaction. That's the first step. Step 2, shear force calculation. Step 3, bending moment calculation. Now step 4. What will be step 4? We should now draw the shear force diagram and the bending moment diagram. Shear force and bending moment diagram. For your shear force and bending moment diagram, what you are doing, those values you've calculated for shear force, you want to plot it on a graph. Similarly, those values you've calculated for bending moment, you want to plot it on a graph. Say this is your graph sheet. For shear force diagram, take a reference line. This is 0. This is the positive region and this is the negative region. Now, at A, observe, this line means the line for A, this one means the line for C, and this one means the line for B. Now, check your book. What is the shear force value at A? At A. 3.3. So, since this is not a graph sheet, let me just do this assumption. Now, if here is 0, then 43.3 should be somewhere here, right? Is there any value on A again? At A? No. So move on to the next point.
At C, you have 23.3 and 3.3.
If from here to here is 43.3, where will 23.3 be? It should be like somewhere half, abi. So let's just locate it here. Let's say we have it here. Let me put it here. 23.3 kilonewton. What's the second value? 3. 3.3 is still in the positive region, and that should be here. 3.3 kilonewton. Any value at point C again? What is on to the next point? What is the first value? Minus 36.67. Okay? 0. Then what you should not do now, those points, your pencil or your pen, bring those points, join it together respectively in that manner. Meaning at point A, from 0 to what? From 3.3. Or point B, what is the first value? So this line, it will meet 23.3 kilonewton first. So you have something like this. Abi? The second at point C, the second one is what? 33.3 kilonewton. Right? Yes. Then the next one, what do you have? Then you have this. Yes. Then shade. Positive, negative. Right? Shear force diagram. You are done. This is the diagram. But I'll show you something. How to draw shear force and how to draw shear force without calculation. All this line without meaning. You will see that. Let's do bending moment diagram. Similarly, take a reference line for bending moment. At A, what's the value of bending moment? 0. This is the point, right? At C, what's the value of bending moment? Let's assume that 66.6 is here. 66.6 kilonewton meter. At B, what is the shear force value? 0. Any value again? No, join. Shade as well, positive. Then right, bending moment diagram. Then you are done.